Hello, this is again another chapter from BTC Tutoring. We're going to be looking at Chapter 2 Review, Descriptive Statistics. There is a worksheet that's also available online, and you can grab that as well. The Chapter 2 introduction is after we have done data collection processes that we showed in Chapter 1. The variables are presented in various ways to show the distribution of data. Additionally, computations from the data show the central values and the spread of the data. The organization of variable values is called descriptive statistics. Our learning objectives in this chapter are display graphs and charts to be able to interpret the data. We're going to look at histograms. We won't look at bar graphs in this particular review, but it shows you in the worksheets, and box plots. We're going to compute and describe the central measures of the variables data, which is the mean, median, and mode. And we're going to compute and describe the spread measures of the variable data, variance and standard deviation. We're going to find the observed location measures of the variable data, which is called quartiles and percentiles. In Chapter 2, we're going to look at various symbols that are going to be used throughout our statistical work. We're going to look at something called the mean, which is mu for the population. And we're going to see the population standard deviation, which is sigma. And finally, we have something called the population size, which is a capital N. Our sample mean is going to be shown as x bar. And our standard deviation, we're going to either have it as S or SX. I like to use the SX because it is shown on the calculator. And finally, we have the sample size, small n, and we're going to see periodically this idea of frequency of observations, which is F. And you'll recall in the last chapter we talked about frequency as being the number of observations of a value of x within the sample. So we're also going to look at the sum of values of x, so that all of the values of x within a sample add up. That's the sum of all values, and we call that the sum of x. And it's represented this particular way. The math formulas used in this chapter are the following. For the population, we have mu is equal to the sum of all the x's in the population divided by the capital N, which is the sample size. And for the standard deviation of the population, we have sigma, which is equal to the square root of the sum of the difference of x minus mu, quantity squared, divided by n. X minus mu is called a deviation, and we just sum up the deviations for each value in the population and square it and divide it by n, and then take the square root. If we didn't take the square root, we would have what was called the variance. So now we have to calculate in our chapters the sample mean or sample average. We call this actually x bar. So x bar is equal to the sum of all the x's in the sample divided by little n, which is the sample size. The sample standard deviation Sx is equal to the square root of the deviation squared, x minus x bar squared, divided by n minus 1, which is considered the degrees of freedom of the sample. In this chapter, we're going to talk about several definitions. We've already talked kind of about how to calculate the sample mean, or the average. It is the central measure of the data set for a particular measurement variable. So if we had the average height of all male students in BTC, we would need to take a sample of those students, measure their heights, and then we could take an average of those heights, right? We could sum up all those heights of the sample and divide by the number of students we sampled. That's the average. The sample standard deviation, Sx, is a spread measurement for a variable in that data set. Essentially, the spread measurement, the sample standard deviation, is really called the average spread, or the average spread difference between the values that we get and the mean value. The sample median is represented by m, typically on your calculator, and it's the middle observation of a sorted data set for a particular value. Theoretically, not theoretically, actually, the middle observation is at the 50th percentile, and so the median is at the 50th percentile of the data set. The sample quartile, the first quartile, Q1, is the 25th percentile data observation for a variable's data. The 25th percentile of the data observation for a variable data. And the sample quartile, the third quartile, that is, Q3, is the 75th percentile of the data observations for a variable data. A percentile, therefore, is the point in the sorted data set where the percentage of observations is below this point. We're going to look at an outlier. It's a point that appears extreme in relationship to other values of the data set. Eventually, we're going to be able to determine outliers through a measurement called the z-score. And so we'll use the z-score to find outliers ultimately. Finally, or the next three ideas, the interquartile range measures the distance from the first quartile to the third quartile, and it is used in box plots. The mode is the most frequent observation of values within a data set. And finally, the relative frequency, the calculation of frequency of x divided by the total frequency of the sample. So here we get the relative frequency is equal to the frequency of x divided by n, which is the sample size. That's the total frequencies. So here we're going to have an example. College students were asked how many hours of sleep per night on average each student gets during the school term. The following data was collected from a random sample of 50 students. And there's our table. It goes from 4 to 10 hours, and the frequency will add up to 50, but we get 2 for 4 hours, 5 students for 5 hours, 7 students for 6 hours, and so forth until we get to 3 students are sleeping on average 10 hours a night. That must be nice. It says the question is find the sample average, standard deviation, median, quartiles using the TI 83 or 84. So now we're going to show you a video of how to do that. So the first thing I'm going to do is hit the stats key. And when I hit the stats key, I get the edit. I'm going to hit enter, and then I'm going to put the values L1 for the X values, the hours at night. And you can see that I'm entering in on the calculator 4 through 10 in L1. And in L2 is going to be my frequencies. And you can see that that is being entered into the spreadsheet for the edit function under stats. Once we get to that point, we will hit stats key again, and we'll move our cursor over to calculate, and we'll use one variable stats. We'll leave the list as L1, and the frequency we're going to hit the second key and the 2 key on your calculator. That'll give us the L2, and then we're coming down to calculate. And you can see when I hit enter, I will get X bar. In this case, it's 7.28 hours. And I can toggle up and down using my arrow key. The median, by the way, is 7. And you can see Q1 is 6. So you can do all the calculations on your calculator. So in this chapter, Chapter 2 review, we've summarized so far general math formulas for average and standard deviation. We've covered the definitions of various descriptive statistics. And finally, we have used an example using the calculator to find average, standard deviation, and the mean Q1 and Q3, as well as the minimum value and the maximum value. Our Chapter 2 amendment is going to be on graphs like histograms and box plots, so that's the next section.